What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to do something completely different to what we've usually been doing on this channel. I'm actually going to go through a revision of some year 10 chemistry stuff because one of my classes at the moment has an exam coming up and I thought this would be a really easy way to help them revise. So please bear with me. I know it's not math related, but we are going to do some addition and subtraction at some point. So what we're looking at is how to make sure we've got the correct chemical formula of a compound based on the ionic charges that would be made by each element. This is something that is fundamental to our chemistry, and if we're on top of this, I guarantee you're going to pass a lot more of these chemistry exams without really having to do much extra work. So there's only 3 skills that we absolutely need in order to smash this topic. The first one is we need to be able to read the periodic table, and this is something we can do at the very start of an exam. As long as we know the very basic fundamentals for this thing, we can use this to our advantage without having to really remember anything. The second thing we've got to be able to do is add and subtract in order to get to 0. This is something we're going to practice, but I think the mathematics behind it is actually pretty cruisy. The last thing that you have to do is absolutely take your time. This is the most important skill. Please just make sure that you take your time and write down any information that you need in order to get these correct. If you do this, I guarantee you're going to find the actual theory behind it incredibly easy. So the first skill we need is how do we use our periodic table? What we're really asking here is how many electrons would I need to add or subtract in order to get a full outer shell, right? Or have 8 valence electrons. If you're not on top of doing that, don't stress. We can just remember exactly what we need to put on our periodic table that we give you. And this would be the first thing that I would do in an exam so you don't forget. If you've got it there in front of you, you can't really make a mistake. So working from left to right, all we need to do on top of each column of our periodic table, we just need to put the charge. So in that left-hand column, the alkaline metals, I just want you to put 1+. Then we move over 1 into our alkaline earth metals, and that becomes 2+. I want you to skip the transition metals and then go to 3+. Once we get to 3+, I want you to go all the way over to the right. Those noble gases don't have anything. We're not going to touch those. But the next one over, starting with fluorine, we're going to have 1-. Then the next one is 2-, then 3-. That carbon gets a little bit confusing. I just want you to put plus or minus 4 on this one, because it could lose 4 electrons and have a full outer shell, or it could gain 4 electrons and have a full outer shell as well. So whatever you do, just have that plus or minus 4 there and it will just help you out. But again, we don't need much more than this. If this is the first thing you do in your exam, you will find these questions way easier because we can just use this information at the top to really help us out. So once we've got the charge there, in a question, we're going to ask you about different elements. The only thing that I want you to do is identify the element, so write down what letter it is, and then look up the top of the column and also write down the charge associated with that element. If you do this, I guarantee you're going to find it pretty cruisy. This is just something where students that miss this are just being a little bit lazy. Look at the element, look at the thing at the top of the column, and you're good to go. So a multiple choice question could look like this. What's the correct formula for calcium fluoride? All I have to do is identify the elements on my periodic table, write down the letters that go with it, and then also write down the charge. So calcium is down here and fluoride's over here. Calcium is in that second left-hand column, so it's got a 2+ at the top. So I have to write Ca 2+. Fluoride's all the way in that -1 column, so I write down F -1. If you've done this, you're like halfway to getting this right. This is where my addition and subtraction come in. I need to get these two things to equal 0. Because calcium's 2+ and fluoride's 1-, I need 2 fluorides to make it +2 and -2. So that means my answer is Ca F2, done. So the other method you could use is this crossing over technique, and all you've got to do for this one is take the charge, so that 2, and take it down to the bottom of the F. And then because fluoride is 1-, I need you to just take that 1 to the other side. This would become Ca1 F2. We don't write 1s down, so the answer is Ca F2, and we know we've got it right. This next question is a little bit more work, but just writing down what the charges are for each one is the main important skill. So I've got K to S. All I've got to do is identify where K and S are, write down their charges, and see if it would equal 0. So K is a 1+ and S is a 2-. because I've got a 1 plus and a 2 minus, I need 2 Ks in order to make this balanced or equal to 0, so it's got no charge. 2 Ks, 1 S, that's what's already written there, so this one can't be incorrect. The next one I've got beryllium and phosphorus. So beryllium's here in this second column, so it must be a 2 plus, and phosphorus is a 3 minus. Using our crossing over technique from before, I would know that that has to be Be3 and P2. Another way you could think about this is if I've got Be2 like in the question, right? That would be Be2 plus twice. That makes a 4 plus. That phosphorus is 3 minus. If I've got 3 of those, it would be a -9. 4 and -9 are not the same, so this must be incorrect. Usually in a test, I would highly recommend doing the next two just to make sure that you've done your working right, but I'm happy with this. As long as our charges do not equal up to 0, we know it is not a correct formula, so this one's done. So with those transition metals, they can have different ionic charges. So something like iron could be 2 plus or 3 plus. And we don't need to get into why this happens in this level of chemistry, but just knowing this, that it could have different ionic charges, is incredibly important. All that means is that you need to really identify what the other element's charge is in the question. If you do that, you're going to be absolutely fine. So if I have a look at this one, what is the charge of the iron in the formula Fe2O3? So this is kind of tough. It's not immediately obvious what I need to do. But if you write down the charge of oxygen first, I guarantee it's going to make sense. Oxygen is equal to 2 minus, right? That's its charge. And this one's got 3 of them. So the oxygen in this chemical formula has a total charge of -6. That means I need that my ions, my 2 ions, to equal to 6 plus. Because there's 2 ions and I need to get to 6 plus, they must be 3 plus. So my answer here is just +3. Because again, we've got to get to that 0. The jumping off point for these questions is getting the element that we know. If that charge is down, we're absolutely cruising. So for this one, we're looking for, hey, what's the correct formula for CRS? Again, CR is in that transition metals, so it could be 2 plus or 3 plus. We're not 100% sure. But that S, we could know for sure that it's a -2. Because I've got 1 CR and 1 S, CR has to be 2 plus in order for them to cancel out and have a neutral charge. So that means I know for sure it's going to be A or C. I know that the answer for this one is A because sulfide, that ide, means that it is by itself. So that's just an S that's hanging out. That ite means that it would be part of a polyatomic ion, which this one's not. So A is my answer. Even though this might be that next step for us, being able to have a guess between A and C is incredibly helpful. And again, this just comes from recognizing the ionic charge of that S first, and everything else flows from there. So these polyatomic ions actually look a little bit harder, but we tell you what the charge is. It's going to be on the front of your page. So that means we actually have to do less work than what we've been doing in these previous questions. The only thing you've got to make sure is that if you need to put brackets in, please remember to do so. So we could ask you, for example, what's the correct formula for ammonium chloride? Right? This could have multiple choice questions, but this could also be like a short answer response as well. We're going to tell you that ammonium is NH4 plus. So its charge, both the N and the H, its charge is 1 plus. Chloride, if we identify that on our periodic table, that's in the -1 column. So if NH4 plus is a +1 and the chlorine is a -1, we only need 1 of each. So that means my full chemical formula for this is NH4Cl. And we're done. For this one, we'd need to know the correct formula for magnesium phosphate. And again, we're going to tell you what phosphate is. It's PO4 -3. Magnesium, I can see, is that 2 plus. So again, I need these two things to equal 0 in order for this formula to be correct. Right? Here's where I would highly recommend using that crossing over method. Because I've got the 3 negative, that goes to the other side, so I've got Mg3. And because I had 2 plus, that goes to the phosphate. So I've got PO4 all in brackets with the little 2. Mg3, having 3 of those would give me 6 plus, and having 2 phosphates would give me 6 minus. So I know that this thing is totally balanced. So whichever way makes more sense to you, please do that way. But the skill here is just identifying that magnesium's 2 plus. please just write it down because you will get these right. Finally, we could have questions where we're given an unknown and you need to tell me what the charge is. And again, this is incredibly easy. Write down the charge of the information we know and just work backwards. So I've got X3N. Nitrogen, that's it, 3 negative. Because it's 3 negative and I've got 3 X's, each X must be a +1 charge, and that's all I've got to do. I need this thing to be neutral or to equal 0. And this can even be done for harder questions. This is a much larger compound that we've been dealing with, but the skills still translate. So because I've got P4Y6, I need to know what the charge of P4 is. Phosphorus is a 3-, and there's 4 of them. So that means I have to have 12 negative in total. So that means the charge of the P is -12. That means that I need those 6 Ys to also equal 12, but positive. 6 divided by 12 is equal to 2. So Y has to have a charge of 2+. This would make these two things equal 0, 12 minus 12 plus. And then I've got a fully balanced chemical formula. So this is all you need to know to excel in this topic. Please, at the very start of the exam, write down the charges on top of each column on your periodic table. And then when you're attempting a question, please write down what the element's letters are, right? Its symbol, and then definitely tell me what the charge of that element is. If you do these two things, the rest of it kind of makes intuitive sense. We just have to get these two numbers to equal 0, however possible. All you need in order to get this right is just take your time in these multiple choice questions, and I guarantee you're going to find success for this topic. Thanks so much for watching, and I'll see you later.